using physics to understand. So this is a related problem, which is, you can watch videos like this. This is Jonathan, who's also in the audience. Well, videos like this, if they would play. Just work a moment ago. There we go. So you can watch Jonathan pick up his pet stuffed rat. And you can see enough of these in order to figure out, OK, Jonathan is picking up the rat. And I can give you labeled videos, and you can eventually learn what the word pick up means from this context. And we have this vision language model. It's the same one that we were using from the previous task that does joint in over observations from the video and for the sentence that we're looking for. So we can figure out simultaneously what do the words mean, what's the correct structure of the sentence for this particular video, and exactly which objects we should be tracking in the video. But the problem is, all of a sudden, you can see an activity from a completely different point, or you can see an activity that's done in a slightly different way. If you imagine this monkey is very heavy, like a bowling ball, you wouldn't pick up a bowling ball and just lift it up off a table. You would slide it off. Well, that's what's happening here. And if you look at the 2D motion of this object, before it was moving upward, and now it's basically moving downward in the video. So if all you're doing is action recognition based on 2D features in videos, you're going to get this wrong 100% of the time. You can't train on the first scenario and test on this one. And basically, the entire action recognition community only works with 2D features. But lest you think that this only happens in weird cases, you can watch videos of completely different animals picking up other animals. This is a cat picking up another cat. It looks nothing like the previous video. It doesn't seem as if the 2D or the 3D features are invariant between these two scenarios in any way whatsoever. But what is invariant is the basic physical description of what's happening in terms of forces, contact relationships, and supports. So one way to think about these videos isn't that the object is moving up or it's falling off the table. It's that first the object is supported by the table. And then an agent comes around and makes contact with the object and applies a force, and the object then is supported by the agent, not the table. With that interpretation, you can train on the first video and test on all the others, as long as your hypothesis space doesn't have to do just with the 2D velocities of the objects. So what we did is we took this 3D object model and we've been changing it in order to re-express the meanings of the words in terms of these higher level concepts and forces, contact relationships, and supports. Now, hopefully in the next few weeks, we'll be changing it to have it infer 3D information about the scene, not just have these expressed in terms of the 2D relationships. We were very skeptical with 3D until we realized that even though 3D from monocular images is extremely difficult to extract, it turns out that when it's difficult, it doesn't matter. You can't really estimate the distance between me and that window because it's kind of irrelevant. But as soon as I start interacting with an object, or as soon as I start walking towards an object, our relative distances, or our absolute, and sometimes our absolute positions, become much more relevant and much easier to recognize. So the idea is we're just going to extract the 3D features that matter. And then we're going to train on soccer videos and test on football or cycleball, because after all, kick is the same in all of them. Thank you.